So we're going to be finding normals, and we'll talk about what a normal is, using the parametric vector and slope y-intercept form. Essentially, we're going to move from a question that is in parametric form to vector form, and then relate vector form to slope y-intercept, which will help us find a normal. And a normal is a line that is perpendicular to our vector. Okay? So, we're in our parametric form, and we want to move to our vector form. Remember, our vector form usually being written as vector r is equal to r naught plus, pluses always look like t's, plus t a b being the directional vector. So, in order to relate that, we can write it kind of like this. xy is equal to x naught, y naught, plus t, and then our a, b being our directional vector. So we'll relate these values. This is our x in this equation. Our x naught is -5. T is obviously t, and a is the value of +8. Same idea with y. Y is y. 2 is our y naught, and -3 is our value of b. So to put it back into our vector form of an equation, our vector form, and we're going to replace x and y with vector r, is equal to this coordinate of -5 and 2 plus the parameter of t and directional vector of 8 and -3. Okay, so we've put that into a vector form. The next step we want to do is relate it to slope y-intercept, and we may be a little rusty with that. Slope y-intercept is our y equals mx plus b, m being our slope, okay? And more importantly, which will really help us make sense of this, our rise over our run. And b is our y-intercept, okay? So, first thing we're going to do is work with our slope. Does anyone know which of these values that we have in our vector form would relate to slope?
The second one.
The second one. The positional vector is going to relate to slope. And actually, we're going to bring out a graph here so we can really get a visual of what this might look like. Oops, that's not what I want to do. Sorry about that. Okay. So we have our positional vector, which is at 8 and -3. So we have to go down a little. We know it's going from the origin. We can relate this to slope by essentially making this look like a triangle, if we like. Our run, which is how far we go on our x value, from this coordinate we know is the value of 8. Okay? We know that this distance here is 8. And our rise, we know is essentially our y value. How far we go along the y-axis to get to our point, which is the value of -3. Okay, so here's our y, here's our x. So in this case, our slope, which is m, our rise is -3, so we'll put it in green. This is our rise. And our run is the value of 8. So our slope is -3 over 8, which can really just be written as the negative value of 3 over 8. So here's our slope in this question. So we can put that in for our value of m. Okay. Y is now equal to -3 over 8 multiplied by x. We don't know our b value. We don't know what the y-intercept is of our specific vector. The positional vector is very simple. It's at 0. That's our y-intercept. But this positional vector is related to our vector that's going through this point. So it's the same slope, but going through the point of -5 and 2. So it'd be -5 and 2. We'll just... Actually, I can copy it, I think. Whoops, not what I want to do. Is it 1? No, it's 2. Oh, sorry, you're right. I wrote it as 1. That's not working. Okay. Negative 5 and 2. Okay, so essentially we have a vector that is of the same slope, maybe something relatively similar to that. We're not exactly sure what the y-intercept is. So in order to do that, we know that this coordinate here of negative 5 and 2 are an x and a y value. So we can relate that to our slope y-intercept form. In fact, we have a x and a y value we can plug things into. Our x value being negative 5, and our y value being the value of 2. So we plug these values in to help us find our b. So we have 2 is equal to negative 3 over 8 multiplied by negative 5 plus b. Will give us 2 is equal to positive 15 over 8 plus b. Our b value will be then 16 over 8 minus 15 over 8. So our b value is 1/8. Okay. So in this case, our y-intercept is an x value of 0, right? Whenever we're doing a y-intercept, we know our x value is 0. And our y value is 1/8. So very close to the origin, but not exactly where our positional vector was. So now that we have that information, we're looking for a normal. And a normal is a line that is perpendicular to the line that we were on. So let's do our best here. Look roughly something like that. Okay. We need something that will be perpendicular to this, which means we're going to have a positional vector for our normal that is perpendicular to our other positional vector. So that's very important. What that means is the slope of our first positional vector can be related to the normal, very simply. Does anyone know how to change something in y-intercept form to a perpendicular slope? The negative reciprocal. So once we have the slope of m being negative 3 over 8, we find the negative, oops, I was going the wrong way there. We're looking for a negative reciprocal. Okay? So the negative reciprocal of this, we multiply this by negative 1, that would give us our negative value, so we now have a positive fraction, and it would then become 8 over 3. So we flip it and we change the sign. Had it been positive, it would have became negative. So the positional vector of our new normal, oops, let's write in the coordinate of this being our rise and this being our run. Okay. Run represents x, so we have a value of 3, and our rise is 8. So if we were to make this a positional vector, 3 and 8, when we put it on a graph, is over here, 3 and 8. So our new positional vector for the normal is perpendicular to our other positional vector, so that looks good. The only difference is this is perpendicular to the normal, and we needed it perpendicular to the original vector. Okay? Which means it needs to go through a point on that vector. And there are an infinite amount of points. We're just going to use the point that we had from before at negative 5 and 2. So if we were to write this equation of the normal, okay, we're going to write it in vector form. Our normal, call it n, goes through that same coordinate of negative 5 and 2, so that hasn't changed, plus our parameter, we'll call it s just to not get confused, and our new positional vector of 3 and 8. So that's the normal to the original equation we had in our parametric form.